almost identical. It's graphing form of quadratics and graphing form of absolute values.
Because I tried to do an equation for it based on the vertex and like how it was shifted, but then when I did that, it wasn't the same as how the points were lined up.
So I see a 0y, 0y, 0x. Those are always really good indicator points.
Wait, what are the homeworks? Sorry.
You're good. Just grab that graph paper and then we can write that down in just a second.
31, 33, and then from the other chapter is 42, 43, 44.
So our zeros allow us to derive what for the equation?
The vertex.
Ooh. The binomials, Shaya said. And I doubt that you're disagreeing with that, but I'm thinking vertex is the next step, right? So first, zeros. So this allows us to say
Yeah, because you get the binomial and then you
x plus 2, because negative 2 is a 0, and x
Oh, I forgot to do the x-intercept thing.
minus 5 starts to build our equation. Then, this 0
tells us what they have to multiply.
Minus 10 outside of it.
not necessarily.
No, that's multiplying it
Wait.
together.
Since it says, since they multiply together, does that mean like the scale factor is only 1 and we don't have to add like a 2x or a 5x?
Well, we don't know yet. So this is why this is a really good question to go over. If we multiply these binomials, we get x squared minus 3x, nice work, and minus 10. So not that there's a minus 10 outside the binomials, but when x is 0, 0, 0, we should get negative 10. So this actually confirms that this multiplier is just 1, and that there's nothing extra outside of them. But we then got to check, do the other points work with this?
Where's for 2, negative 12?
I'm going to write this down. This seems helpful.
This seems like I'm doing your homework for you, which is fine. But yes, you are right. This does seem helpful.
Okay, so you put them in like.
You plug in x for x.
Yeah, test a few of them and just confirm it.
Wait, I'm gonna go over another piece of graph because I want to write like this system down.
This is
I don't think
interesting.
it works for negative, just one negative data.
This is interesting.
Well, that means that the vertex is 1.5.
Ah, that means the vertex is in between them.
Exactly.
So our vertex would have an x value of 1.5.
Parabola.
1 squared is 1, minus 3. Positive 1, minus 3 would be negative 2, minus 10 is negative 12. I think that works for 1. 1, 12? Or 1, negative 12? My question is, does it work for 2, negative 12?
Wait.
2 squared is 4, minus 6 is
negative
negative
12,
2.
I said it worked.
Yeah, so actually I think it works for both of these. So I think our equation is correct because it confirms at least 4 points.
Can I please have Vera Gammon to the office? Vera? Thank you.
Anybody else? Would you like to call anybody else? Should I hold my breath, wait for the boo-doo-boo?
Should we, like, make the graphs? I didn't we try?
It just says write the equation of the quadratic function containing the points, then make a complete graph. Now here's the thing about complete graph. If we indicate the zeros and the vertex,
That's a complete graph.
it's pretty much everything we need. So I would plug in 1.5 to figure out the y value of the vertex, and then we're pretty much good. We should start spending more time, which any time is more time, going over homework problems that are tough ones.
So wait, the vertex was negative 13, right?
I don't know, 1.5 squared is 2.25. I think it's 15 squared is 225. So I think 1.5 squared would be 2.25. Minus 3 times 1.5 is 4.5. Minus 10, so negative 14.5 plus 2.5, or 2.25.
And also,
Is it negative 12.25? Math is hard for me today.
I think we could do this even if we only had the 5 and the negative 2, because I don't think the negative 12 is really necessary. Like, it's nice, but you could also find the midpoint between 5 and negative 2.
So this and this point, you're saying the midpoint of is 1.5.
Yeah. And I think it should always be.
So are you saying if I only gave you those 2 points?
3. I think we still need the 0, negative 10, because it could, like, stretch out.
We need at least 3. 5 for quadratics is better. If you're asked to like make a table or something, sure, 3 does it, but 5 is better. So we normally go vertex is the middle point, the zeros, and like you can either do points in between the vertex and the zeros or outside your zeros, but we normally try to list at least 5 points.
No, that makes total sense that you want to list 5 points. I was just trying to...
You're right though. I mean, 3 points is our minimum, right? 2 points for a line, right? If we just have a line, you can do it with 2 points. 3 points for something that's curving. And really, if it's exponential, are 3 points enough? Yeah, like, sure, 5 would be better. I mean, I like to say 5 is always the way to go.
Now, like, 50,000 would be better.
I mean,
Or
more.
Maybe it wouldn't be, because then you'd have to calculate.
Yeah, there's a certain point where you're like, okay, that's enough. All right, other questions? Actually, you look like you want to meditate right now. How what?
How each one won the tic-tac-toe.
Yeah, I wasn't here. I was in Mexico when they came around with the tiles, which seems weird to say because I've barely ever left the country. But I didn't choose these. I like Sombrero Cat. The tic-tac-toe one's just kind of interesting.
It's people from last year.
I kind of want to pull down some tiles and
It's semicolon either.
I want to do math formulas up on my ceiling. But
Take out a tile.
You should replace that one with the one in Miss Pettigrew's room that has 4 different seasons for no reason.
I know, but I didn't get to choose. Like, then I would just be stealing hers, and that would be kind of rude.
Yeah.
All right, other homework questions. Other homework questions. I am slightly taller than Pettigrew, so I'd probably have an advantage. Just if we're trying to reach the ceiling, I think I can stand on the desk and reach the ceiling.
We're trying to reach the ceiling, yeah. You would have an advantage in that.
What, did you think I meant like to fight her?
Fight, and I was like, but it's Pettigrew, so I don't know.
Oh, I would never fight Miss Pettigrew.
Yeah, it would be illegal.
I am, well, not only that, but I am afraid of her. Oh, tell me you're not afraid of her.
No,
Miss Pettigrew was nice.
she's chill.
Maybe
like,
you.
I wouldn't want to, like,
I don't want to fight anybody.
All right, so here, I have never been in a fight ever. Here, we skip 32. I mean, there are not many occasions where fighting is necessary. I've been in, like, an argument where people, like, you know, shove each other, but, like, I've never been in something where people are swinging on each other.
okay, you had a weird childhood.
Okay, when you're a kid, when you're like, man, that's not really a fight. I mean, like, someone gets punched in the face, sort of. Like, there's no need for that. We can solve our issues with words.
One time I kind of punched myself in the face with someone else's head. That was so good.
That always makes you feel good, right? You're like, ow, this is my fault, but ow. All right, skip 32, and then just 42 to 44. Like, literally just all 3 of those. Cool? All right, so yesterday we started talking about everything that is going to be important today, except for we did not formalize that this is what we call the graphing form. So what we just wrote down is a really good example of not graphing form and kind of less convenient. Because if we have the zeros, great, we've got the zeros. But this is way easier to figure out how to graph. Now, the trap door, this,
That's up and down.
it is not the y-intercept.
No.
Right? So be careful, because that is vertical shift. It's not the
Because you
y-intercept.
have the negative 3 squared in there.
Yeah, so, anyone seen these before? And actually, I don't know what you guys learned in Math 1, because I don't teach it anymore. How do you figure?
Because negative 3 squared minus 4.
No. Wait. Yes.
I think.
Yeah. For a second there, I thought you were saying negative 9 minus 4 equals 5, and I was like, no, that's not how that works.
Grab your graphing calculator. Or, well, okay, if you want to get out your Chromebook, you can. We can use Desmos or graphing calculator.
Desmos is more fun.
You are correct. I agree. I mean, Desmos is just better. You can zoom easier. You can.
Yeah.
What's that?
It's easier to manipulate.
Yeah, and it's easier to see in a way.
Yeah.
Also, the resolution's better.
Whoa, I'm up to 330 subscribers. Hot
Oh, yeah.
diggity.
How did that
So
happen?
much you bought.
It's a bot. I love the Reddit bots. Like, and how people, I don't know if you guys are on Reddit or not. I never was till I was like old
I'm on
and.
Reddit sometimes when I'm looking for game strategies.
But there's like bots that just like automatically do stuff, and then people vote by saying either good bot or bad bot, and there's a bot keeping track of the bots, which bots are better than which bots. Like it's
What's the highest ranking bot?
I'm not
Is it the one
sure.
that keeps track of all the other bots?
Probably the bot counting bot is the top bot.
Well, yeah, it's rigged.
I mean, wouldn't you write your own code so you could win?
Yeah, or just like people are like, oh yeah, I like this bot because it lets me vote on other bots.
If we graph x minus 3 quantity squared, we use the word quantity to clarify and make sure that we are talking about squaring a binomial, not just the 3.
What if it's a trinomial?
You'd say the quantity of blah 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 squared. Like you often will say the quantity first before the power happens. So the quantity x minus 3 squared is telling you the x minus 3 is in parentheses.
Yeah, I get that, but sometimes you say like the quantity of something times something else as well.
Yeah, and that, so if I had like a 3 in front of here, I'd say 3 times the quantity of x minus 3 squared minus 4.
But what if
Makes-
the 3, what would you do if the 3 was inside? If it was 3 times x minus
That'd be the quantity of 3x minus 3 squared.
Oh, because
The quantity of tells you parentheses.
yeah,
It's
yeah.
literally like saying open parentheses, open sesame. It's like, but instead of saying open parentheses, because that's kind of silly.
And there's no reason to put like 3 times x inside
Yeah.
of a parentheses. You can simplify it down.
So when we graph this, click around, and this is also why I like Desmos. All right, so there's 5. So I think it was Jake who said 5 is one of the zero. Wait,
No,
or 5 is the y. There's 5 also. Well, hot diggity.
That's a lot of 5s.
What about this point down here?
It's the opposite number of inside the parentheses, and then it's just a y.
I think that would be different though if we added like a 2 to the beginning.
This? Play with it.
Wait, no, it wouldn't be.
It doesn't make it skinnier.
Negative 5. It still doesn't change it into
Oh. I showed the quadratic formula song to the 7th grade. And now, like, if I say negative, like, kids will start saying b plus or minus the square root. Like, they don't even know what they're singing. They have no idea what the quadratic formula is. But yet, they start singing it.
Well, it's gonna help them memorize it once they know what it actually is.
Right? That's my secret plot here. I'm like a villain. This is what we call HK form.
Oh, vertex formula. See, we
Heyo.
talked about this and it was on a test, but I never remembered it, so then I had to search it up.
So, in your notes, what you might write down is if we have a function x that is x minus h squared plus k, the vertex is HK. Now the trapdoor is, notice that minus. So what H looks like it is, we take the quote-unquote opposite of what it looks like inside the binomial, but really, since we write this formula x minus h, h is h, right? So that's where this gets tricky, but this is how they write it. Otherwise, if we wrote x plus h, we'd have to put the opposite of h over here, right? So like however you want to remind yourself, but if you look up like graphing form, vertex form, whatever of quadratics, you're gonna get x minus h squared plus k.
Yeah, I think this one makes more sense because it makes the vertex look nicer.
Here's what's really nice about once we have the vertex, we just work out from there. You can. So, well, you'll have time to do that because we're going to run through a couple of these and then we'll run through a couple absolutes. So from there, since you know the vertex, and actually we can then take this and put it into the form to get our zeros, or is there a different way we could get our zeros?
A different way we could get our zeros?
Yeah, so like I could square that binomial and subtract 4, which Jake did pretty quickly to say, oh, 5 is the y-intercept.
Wait, if you add them together, I don't know if this is like actually how this works. You're just some weird.
Well, yeah, because we're learning. Go ahead.
But if you add positive 4, wait, no.
Like to both sides.
No, never mind.
Well, hold on. Keep that train rolling.
So, I was seeing if you take the positive 4 and then you subtract the 3, you do get 1.
Well, can I wait? Subtract the 3.
Oh, wait, yeah. What you wrote down makes more sense.
Well, I wrote down what I thought you were meaning, but I haven't subtracted the 3x. I don't trust you.
No, I didn't realize that you put the. Okay, putting the 4 over to the other side makes more sense than what I was saying. Basically, one of the x-intercepts is 1, 0. And I was
Well,
like,
we know that because we put it in Desmos, but what if we didn't know that? Not like, I'm not trying to stop you talking. I'm trying to push your thinking. If we didn't know the zeros because we didn't graph it yet, what does this look like? We've seen stuff like this year.
Wait, that's like completing the square.
That's like completing the square form. What would we do on both sides here to work towards isolating x? Square root. What's the secret we got to remember about square root? Positive, negative, right? So at this point, we have two options.
Oh, and those can be the two different.
Oh, careful. Positive, negative. What's square root of 4? 2. So we get positive, negative 2
Wait a second. No, yeah, that's
equals x
minus 3.
minus 3. So
Plus
So,
2
x.
equals x minus 3, and then minus 2 equals x minus 3. So then equals x.
Yeah. And then so 3 plus 2 is 5, and 3 minus 2 is 1. Oh.
and there are our zeros.
And then, oh. And
Not if we isolate x and add 3 to both sides.
you're adding 3 to both sides.
So that's how I got positive 3 with the plus or minus 2. Does that make sense?
Yeah, and can you go back a second?
Like up
scroll
or
up,
to
yeah,
Desmos?
scroll up just a little bit. Like, I feel like if you had a coefficient, is that what it's called? If there was a number outside the parentheses, you would divide by that first, right?
Yeah, inverse order of PEMDAS. Yep.
Okay.
Inverse order of PEMDAS. Ready to try this on your own?
Sure.
See, I'm not making this up. It's written in text right there. Try this one. Try to put this into vertex form, and then we'll deal with it from there. So I know that we could say, okay, the y-intercept here is positive 5.
So what you're saying is basically reverse
not sure. Try it. Try it and then see if that, like, I'm not sure if what we're doing, if my answer to what you're saying is yes or not. I'm genuinely not sure. Just get a head start on me. I don't want to write stuff down quite yet. Don't put this in Desmos first. Try it on your paper.
Oh, you can complete this.
They add to 5. No, they multiply to 5, add to -6.
Oh, that's really annoying.
Remember, they multiply to 5.
No, never mind, that's easy.
I was about to say, I don't think that's really annoying.
Never mind.
I think that's just like mildly.
Wait, you have to add.
See, I would rather us go back to saying like I'm silly, you're silly, than saying like you're wrong or I'm dumb. I hate when kids say I'm dumb. Because also it's like in the moment, right? You're not dumb. What you said was dumb.
Well, yeah, but it's quicker saying I. Everyone knows that it's like in the wrong.
No, but it's self-deprecating.
Yeah.
As opposed to self-defecating, which you don't want to do.
Yeah. I think I got it. I got x minus 3 minus 4, the same thing we just had. Because I did x minus 3
Wait.
squared.
No, wait, I got x minus 1, x minus 5.
What? Oh, no. How did you get that, dude?
Because it has to multiply to 5 and sum to -6.
So wait, Connor, you said.
It's x. I said x minus 3 squared. Because.
And then something out here.
Yeah, minus 4. Because.
Could these both be right?
Yeah. They could be.
Yeah.
Let's plug a number in and
Yeah,
see.
they could be.
Let's plug 1 in. 9 minus 4 is 5, and then that's 0 times.
I'm
No.
quickly gonna do.
No, that didn't work.
I mean, that worked.
Is that
Yeah.
okay?
It did work.
But if you plug in like 1 to both equations, you get a different answer. Because mine gets.
Well, be careful. Remember, negative squared becomes positive. So 1 becomes -2 squared.
Oh, it becomes 2. Yeah, that's where my logic failed. It's
Wait,
better.
why? Why?
Because you're
Because-
multiplying it by itself, not something else.
Because I did completing the square and Jake did shoot, what's that one called?
0?
Jake made yeah.
The zero product.
That's
Zero
what it's
product property. Yeah. Zeros. Oh, and that one shows the intercepts, and mine shows the vertex. Yeah. So they're both really useful.
Both could work.
They not only they both could work.
They were
This is like
yeah.
everything we need to know.
Yeah.
The vertex, the zeros, mic drop, we're done. Because we don't have to have 5 points. If we have 3, we essentially know everything we need to know. Guys, this is cool. Come on, this is powerful. You're looking at me like you're unamused.
Connor, I want to know how you got to this.
What?
That's because we already learned it.
Okay.
I know, but I gotta make sure that we're ready to master it.
I
Well,
want you to
we
Jake
like
how I
to
got
take
to
a
the
whole
square.
test on it too.
I want to
Okay.
know how they got to the square.
So I thought this. I halved this because it times itself
Oh, yeah, you just didn't
because
complete
it's a
it.
square. Yeah, I just completed the square, and I was like, oh, that needs 4 more. So I added 4 to both sides, and then when I was done over here, I subtracted 4.
Neat.
So we did already do this, quote unquote, but back then,
We were doing-
at least if I taught this to you, that we weren't learning it back then. We didn't quite know about vertex form.
You had it on a test.
Well, I wasn't supposed to.
It was the question. It was a question.
I think we were more learning about like this for like quadratics and not so much for well, I guess kind of the same.
Related, adjacent, right? They're adjacent topics, right? So it makes sense that if we're learning one, we might as well learn the other, which is why I do the like over teaching that I do. But yeah, guys, this is especially where like working in groups, If one person sees it like this and one person sees it like that, wham, bang, boom, you're done. Try these.
Well, that first one's just x plus 3 squared.
Nah.
It's just like the last one, except with
Nice flex. Oh, that first one's just.
Sorry,
Oh,
but it's just like the last one was, except for like a little bit different.
I'm trying to get some of my 7th graders to stop saying just because they use it like a weapon. They're like, well, you just have to. Like, they say it with this attitude. And I'm like, stop that. Like, yeah, I mean, it can hurt people's feelings. If you're bad at something, like, so if you come in and you're like, oh, my toilet's leaking, what do I do? I'm like, oh, you just have to take off the 2 bolts and replace the flange and did it. That's not a just statement for most people. That's only on my breaks. I gotta help my dad fix his toilet when I go home next. Okay, so what about B then? You said, wait, so what's our vertex there?
Oh yeah, we need to do it the other way.
X plus the quantity of x plus 3 squared minus 8.
Well, what's our vertex?
Like minus 8.
What? Sorry, I couldn't hear. What's the vertex?
Oh,
What? No. Isn't it 0? It's 0.
The I need 2 points to be a vertex.
It's 3 zeros.
Oh, yeah.
It's negative 3 zeros.
Yeah.
I knew we were doing completing the square for a reason.
Man, you mean your math teacher had an
Somebody planned it
intention?
that way.
It's almost like somebody planned out an entire year worth of content that would progress from one thing to the next thing.
Nah, I couldn't do that.
Actually, I'm not that good.
Could not be. Never could.
All right, what about B? Oh, wait, so sorry. I moved on too quickly. So, guys, what's this really mean since that's a vertex and it's our 0?
It's nice.
The vertex is on the x-axis, right? The vertex is our 0, and there's only one 0, which is the vertex. It's all the same. So the problem with A, we're going to need to get some more points, right? So
Yeah.
my advice, go equidistant from the vertex. So if we're going to go to graph this, we know negative 3 is our vertex. Find a couple more points by going like -1, -5. Now I should really write these in the other order because that bothers me.
And then do 1 and 5 as well.
Yeah, I mean, like we said, 3 is the minimum. So then we could also do, you could go out 2 more if you wanted. So you could do like -7, +1 if you wanted to get 2 more points to be able to visualize it and see it.
Oh yeah, those are equidistant from the vertex.
From the
equidistant
vertex.
from 0, 0.
Yeah, from the vertex. Always go out from the vertex. Does that make sense? Jake, does that make sense?
Yeah.
Okay, just trying to get confirmation for everyone. All right, so how's this factor?
Actually, I was saying it's the same thing as the last one, -8.
Oh, it's x plus, because half of your b. Okay, so x plus 3 squared, but then that would actually be 9, so you said -8.
Half of your b, that reminds me of the quadratic formulas over 2a.
It's all connected. It's all connected. So our vertex here is,
I had it, but then I forgot it.
Wait, it's 3.
No,
It's
it's
negative 3,
-3,
8.
-3, -8. I'm not closing parentheses yet. And then from there, bump out. And honestly, you don't have to go very far. We could just go to -4 and -2. Or, if we wanted to come back up here and say, don't do complete the square form, can we factor, multiply to 1?
It's really not nice.
Yeah, it's really not nice. So this is why some quadratics, you just straight up don't want to factor. It's like, I gotta multiply 1, add to 6?
Yeah, that's
Well, not necessarily impossible.
because you could do like 5.0999.
Graph this real quick. Does it have zeros? Like, throw this in Desmos. X squared plus 6x plus 1.
This one's gonna be really close to 5.
5.828.
Oh yeah.
probably radicals involved in those numbers. If we were going to be precise, like you and I were discussing, if you're going to be precise, we'd probably keep it in radical form. But if we're not asked to find the zeros, if we're just asked to graph it, whatever, just graph it.
Just graph it roughly.
Yep. Questions on doing this with quadratics?
No, I'm good.
Solid.
And now we're going to work on
Vertex
absolute
form is
numbers.
actually a lot easier than factoring, is what you're saying?
Easier is relative. Depends on the quadratic. Some quadratics, the factoring just pops out at you, right? Like, because we've played with numbers so much. So we could do some more practice. We could practice when we have a coefficient here, but it's okay. So like if we look at C, thoughts on what we could do to deal with the fact that,
Divide by 2.
No, 29 divided by 2.
But then you just add. Oh, sorry. If you divide by 2, then
Okay.
you get x. Here, wait. Can I actually go up to the board?
or we could even instead of dividing by 2, you could just factor out the 2 and like hang on to it. You can try whatever you want. I'm all about kids teaching instead of me because I got coffee to drink.
You're right. We could factor out
Just
the
a little
2,
bit
but
left.
I don't feel like it. So we're gonna make this x squared plus 8x plus what's that? 14.5.
So why are you saying this isn't bad?
Because first off, it's a 0.5, so like it doesn't matter. And then also, all we have to do is just add enough to get to what 64.
Well, and when we go to put it in vertex form, what's the number that you're using inside of that parentheses?
The number that like these two. Well, no.
Yeah, it's x squared. It's x.
I think.
Quantity of x minus 4 squared.
Huh?
Thing.
I don't think.
Care of x minus
Or
4.
x plus.
Remember, when we're putting it into graphing form, it's half a b. Right? Isn't that what we've been doing with the other ones?
Yeah. Oh yeah. So it's half of this. So x plus 4. So it's like.
16. So then 16.
You've got all of that open board space, and yet you still persist. Now, wait a minute. Minus 49.5. Where
Because-
did that come from?
8 squared is. No, it should be 4 squared. It should be a much smaller number than that.
So let's
So
say that
like
seems.
See,
One
we're
point
going,
five.
you're standing in the way and your handwriting is so bad.
Sorry. Well, the
Then
board.
move, Jake.
That doesn't fix fucking
It's x plus 4 squared minus 1.5.
I believe you are correct.
You are
let's
right.
let's work it again. Here's the teacher skill too. Doing this so your students can see you. This is what you got to work on when you come up here, because Jake's going to complain about not seeing. So if we have x squared plus 8x plus 14.5, and then we take it to x plus 4 squared, sorry, that would be x squared plus 8x, which we like, but then plus 16. So then we would need a minus 1.5.
Yeah. And then if you need to shrink it, you can.
Will that be the same as 2x squared plus 16x plus 25? Does factoring out the 2 not matter?
Plus 29.
Yeah, what you said. Throw that in Desmos. Let's check. Is this the same?
I feel like it wouldn't. I feel like it's
Is
gonna have a
this
different
J of X?
squeeze factor, you know?
A different squeeze factor?
Yeah.
Is that what Mr. Hall calls it?
No.
Mr. Hall
I came up on this with this word all by myself. We didn't really do parabolas, I don't think.
No, that's like a this class thing.
Not to say I'm complaining, but like parabolas, they're fun.
You have to put a 2.
Do we have to put the 2 back?
Crap, so how do we fix that?
What if we put the 2 in front of the x plus 4?
So what you do, put 2 in front of the whole entire thing, and then you multiply the 2 by -1.5.
So you're
yeah,
saying
you're right.
put the 2 here
And then multiply that by 2.
and then change this to 3
Or you could just,
minus 3.
or a different way to do that is you could do 2 and then write another parentheses around the whole thing.
Ah, we
So
could.
it's like
Now wait, where is our vertex?
our
Negative
vertex
4,
is
negative
Sorry, -4.
negative.
Is it -3 or -1.5?
it is -3. So yeah, it makes more sense.
Ah, so Akshay's way is better, saying if I put this 2 out here,
To
So-
distribute it,
so did we then, does it work that we did this?
Probably. Well, that's like the same thing. And because basically we're putting the 2 on, we're doing, basically Akshai's way is, in some sense, doing what I did and then distributing the 2 to the -1.5. So when you were saying earlier we could just factor out the 2 for later, that's kind of what we did.
So this red part, I think what you guys just suggested we do is this has a 2 out here.
Yeah, because
Right.
we solved the red part and then we.
So then when we distribute, we just leave the 2 in front of this, but we apply the 2 over here.
Yeah.
All right. When you do your homework, we'll then check it and make sure that this makes sense and that we're doing it right. Okay? So try to do your homework tonight because I see you tomorrow and I don't see you Friday here because you have an ELA test or whatever.
Wait, I might do today's homework before I do yesterday's homework.
Sure. That's totally fine. How do we think this relates to absolute value functions?
I feel like absolute value functions.
Aren't absolute value functions like these?
The V functions. Yep.
No, absolute value functions basically work like a line and then they make like an angle and then they just keep going.
In Desmos, throw in absolute value of x, which Desmos is sweet. You can just type ABS and open a parentheses.
Or you can just use the shift line and then.
You guys are better at keyboards than kids ever used to be.
Yeah, it's right on top of your enter.
Yeah, above enter, there's the vertical bar.
There's a vertical bar on a keyboard.
Learn something new every day. All right, then let's play with. All right, so if I put like -3 in here, did it do like parabola did and do the opposite?
Yeah.
So then if I do like -5 out here,
It goes.
is my vertex now +3, -5?
So it works in a very similar way.
Pretty much identical, right?
Yeah.
It's this is also vertex form x minus h plus k.
Because if you think about it, like this is kind of like if you took away the square. Like the square, you can kind of think of as absolute valuing it and squaring it.
Do you know what you're referencing? Starts with a P.
Time
That was such a stab in the dark. This all relates back to every function has a parent form. So the parent function of a parabola is f of x equals x squared. And then we start messing with it. The parent form of an absolute is just absolute value of x, and then we start messing with it, either on the inside of the function or on the outside of the function. Remember, the function is what's happening. So absolute value is what's happening, and then we add or subtract something, right? The addition or subtraction outside the absolute value does not impact it. So if we came down here and threw these numbers through, they're gonna impact that, but if I change this function, we're gonna take the absolute value of x and then, right? It's like an afterthought.
I feel like they buffed up the machines for the last.
Right, they've got like extra gear wheels. I genuinely, it's like good observation. I thought the same thing when I was looking at the textbook. I'm like, oh, they have a fancier machine than they did in 7th grade. So, when we look at, oh my gosh, there's a lot of screens to just skip past this. And we are given the graph and asked to derive it. I bet we can figure out.
X minus 1 squared plus 2. X separates 2x.
This is also why I started to make my ones fancy.
Yeah.
Because when a 1 is next to an absolute value bar, it gets a little messy.
And then you need to do
Plus 2.
Plus 2, and then somebody
But
said
I think
something
it's has
else.
to be
Negative
2x,
in front of it.
because if you look at like how it's, you know.
Oh yeah, put a
Say again what you said.
Put a negative.
Negative in front of it, because it's flipped
Oh,
over.
yeah.
And what's the slope? 2. It's 2, and it's negative 2.
Oh, yeah.
So if I write this, is that correct?
No, it's negative 2x minus 1 plus 2.
Wait, crap. I forgot the minus 1. But so does my negative 2 go on the outside?
Yeah, it does. And there's no parentheses or anything.
Well, there's absolute value bars, which kind of work like parentheses. I mean, you're right. There's no parentheses, but absolute value is a grouping symbol.
I know.
Yeah, so it comes first.
I just meant you didn't have to put any parentheses for like the multiplication.
What if I goofed up and put the negative 2 in here?
Let's check it out.
And actually, it's time for lunch, so we can pick this up tomorrow.
We can put the negative 2 like as a coefficient to the x.
Yeah, inside the absolute. I'm just curious what happens. Is it the same?
It still
No,
goes
it shifts
up.
it. It shifts it one left and it does the thing.
Wow.
And also it goes up if you put the negative 2 inside.
Why?
No.
Yeah, it does.
Why?
Like it opens upward if you put the negative 2
Okay, it's like
inside.
I'm over this. I'm out of here, guys.
What about why?
I like that you guys are still fighting with it. She's just pack it up. She's like, nope, gone, done. Enjoy your pancakes for breakfast.
Ooh, I will be buying those even though I packed for lunch.
Apparently everyone loves the pancakes for lunch, or pancake
Yeah.
breakfast for lunch, whatever it
And
is.
the people who don't get the food are the ones that go.
Whoa, I am one of those people.
Oh, look what Mr. Allen found.
Huh. I thought this existed, like somewhere out there in the interwebs. Have a good day.
Hey, wait, do you have a 1A class?
1? Yes. It already happened.
Well, I was just wondering. So you have to take like lunch attendance?
Yes, it's annoying.
Yeah. I'm like always late to lunch attendance. Like on Tuesdays.
Is it because of choir? No, choir, you.
Because wellness.